right, hello everyone. My name is Rachel, and welcome back to Sorry to Burst Your Bubble, where we debunk all the science myths and misconceptions that are in the science industry. Last week, we talked about microbubbles and how they're used for cancer treatment and science research. This week, we'll be talking about preservatives, all things preservatives, how they're used in the food industry, and how they're integrated into our daily lives, more than you might think. So there are several different types of preservatives that are in the food industry that are vital that we need to know about. The first is natural preservatives. Natural preservatives have been around for a very long time. Synthetic preservatives, on the other hand, are heavily processed and need to be manufactured. So just going a little further into preservatives and how they were introduced into the food market. Preservatives, specifically synthetic preservatives, were introduced around the 1950s. During the golden age of processed foods. This was when a lot of emphasis was put onto scientific research, and processed foods became popular because they were a result of these scientific studies that were being done. They were also extremely popular because of their convenience. Over time, however, this became a major staple in the American food diet, to the point where we went from having 10% of our diet consist of processed foods in around the 1960s to now where our diet consists of about 60% processed foods. So when you're looking at this statistic, it isn't in itself inherently bad until you look at what is going into these processed foods. The synthetic preservatives are integrated very quickly into the food market without a lot of research. In a study that was performed in 2014, looking at sodium benzoate, which is the specific synthetic preservative that I used during my experiment, it was found that the mice and rats that consumed sodium benzoate had much slower reaction times and gained a lot more weight compared to the mice that did not consume any preservatives. This raises the question of how actually are preservatives affecting our health, especially these common synthetic preservatives that are supposed to be safe, but are actually resulting in a lot of health problems. So I mentioned how the mice in this study performed in 2014 gained a lot of weight as a result of eating sodium benzoate. So this raises the question of how are synthetic preservatives actually affecting our weight gain, and are they affecting our weight gain? Because as you look at the trends in obesity in America and the trends with how preservatives are added into our food market, they are proportional to each other. So the more preservatives that are being added into the food market is increasing with the obesity rates in America. So I mentioned before how in the 1960s our processed foods diet only was 10% of our whole diet in America, whereas now it's 60%. So the obesity rates in 1950s were about 10% of American adults were obese, and now it's closer to 50%, which is a pretty staggering result. So looking at how these synthetic preservatives are affecting obesity rates, it's important to note how they affect specifically the thyroid and our metabolism. So the thyroid is responsible for sending out the hormones in our body to keep our metabolism healthy and to tell our body, hey, you have a lot of food that you can process into energy. As time goes on, naturally the thyroid will slow down these hormone messages that make our metabolism run. But because of these preservatives that are being added, specifically sodium benzoate, it's thought that they are causing our thyroid to not send out these hormones as often. This will lead to increased weight gain at a much earlier age. And as a result, we are seeing much higher childhood obesity rates within America. So if the metabolism is slowing down and the thyroid, any organism, specifically humans that eat sodium benzoate, will see obesity rates. In addition, I mentioned that these mice had slower reaction times after eating the sodium benzoate over a consistent amount of time. So a conclusion that study had was that mice would have decreased cognitive function as a result of eating sodium benzoate. So all of these claims were made within the study, and I thought it was really interesting to look at how preservatives are actually affecting us, because we can't really avoid it all the time because of how integrated into the food market these preservatives have become. So I decided to look at sodium benzoate specifically. And in addition to that, I decided to look at natural preservatives. Natural preservatives have been around for a lot longer. And because they've been around for so long, there has been enough medical research to know that these natural preservatives are not causing any health issues to anyone who's consuming them on a regular basis. So I decided to create an experiment using mice as a test model, which is good for comparative medicine because mice and humans have a very similar digestive tract. And so anything that a human would absorb through the food that they consume, a mouse would also most likely absorb. So I had 3 test groups that I looked at. I looked at a group of mice that only ate organic food and water and did not have any preservatives in their diet. I had a test group of mice that would eat only natural preservatives and the same diet as the control group. The natural preservative I looked at was citric acid. It's very similar to sodium benzoate in how it's used in the food market and in other applications, so that's why I chose this natural preservative. And of course, sodium benzoate, which it represents the synthetic preservative, was used in the 3rd test group. So I had 3 test groups of mice. I bought them from a local pet store, and they were initially intended to be used as feeder mice. So I wasn't using any mice that I wasn't lowering the quality of life of any of the mice through my experiment. I had 6 enclosures in which housed 5 mice each. So there would be 2 enclosures per test group. Each enclosure had a bottle of water in which I delivered the preservatives to the mice through their drinking water, and bedding, and they all had a wheel so that they wouldn't mentally become bored and mentally fatigued, so that they wouldn't become depressed throughout the experiment. I tested the weight gain of the mice by weighing them every week. I was hoping to discover a statistically significant difference in the amount of weight that each mouse group gained throughout the course of the experiment. I expected that all of the groups would gain weight, but I wanted to see how much of their body weight, percent body weight they gained from the start to finish. In addition to their weight gain, I also looked at their cognitive function, and I did that by building a maze, and each week I would run the mice through the maze. The idea behind it was that throughout the course of the experiment, they would learn the path of the maze and therefore complete it faster. If they were able to complete it faster, it would show that they had a healthy cognitive function and that they were able to learn very quickly. And if their time slowed down throughout the course of the experiment, it would show that they did not have a healthy cognitive function. I also performed a 3rd experiment to look at the gut microbiome of the mice. Synthetic preservatives are much stronger in general than natural preservatives in how they kill bacteria. Not that they always work better, but they're normally a lot stronger. And so it's thought that synthetic preservatives will actually attack the gut microbiome of whatever organism ingests it. And so I wanted to look at the gut microbiome of the mice because gut microbiome is very important in the digestive process. So if they don't have a healthy gut microbiome, it could also lead to symptoms such as obesity. I tested the gut microbiome by taking an initial feces sample before the mice had a new diet of their according to their test group. And then I took a sample after the mice completed the cycle of consuming the preservatives to look at if the bacteria counts changed from before and after depending on what preservative they consumed. So the experiment that I ran lasted about 6 weeks. Throughout, I was monitoring the mice every day except over the weekends, and I would make sure that they had sufficient amount of food and water. I was making observations about the health of the mice, if they seemed lethargic, if one mouse seemed to be attacked, if any of the mice were displaying signs of sickness. I would make sure that they were eating enough food, and I would know if any of the mice were not behaving in a normal way. So throughout the experiment, there were several important qualitative observations that I made. One was that food aggression was very common throughout the mice, and I did not expect that. All of the mice that I bought seemed to be male, and in the wild, male mice specifically are very territorial, and so they will have their own area that no other male mice will come into, similar to like a lion pride, which is a more common example of male dominance in the animal kingdom. So because all of these male mice were in a single enclosure together, it would make sense that they would have some form of food aggression, especially because they're not able to have their own separate corners and stick to it all the time. Another observation that I noticed that I wasn't really expecting was that cannibalistic behavior was displayed throughout the mice. Initially, when I observed it, I was very shocked and didn't know what was going on. I wasn't sure if I was doing something wrong. But after doing some additional research to figure out maybe, hey, what's going on here, I found out that this is a pretty common problem when using mice for testing. And I discovered that mice are very, very temperamental and will need very specific conditions in order to have a long period of life and to like have a healthy period of life. And so I don't think it was anything that I did wrong with the diet of the mice or with the treatment of the mice that caused them to have food aggression. I believe it was because of the fact that they were all male and territorial, and because of the fact that there was not a whole lot of place for the mice to go and to spread out. So because my mice all unfortunately started dying on me without me expecting it, and because I started out with a sort of small number of mice to begin with, I ended up going from 30 mice originally down to 8. So this significantly affected my statistics at the end of the trial. I performed a one-way ANOVA test to analyze the weight gain of the mice over time, and a one-way ANOVA test to analyze the time through the maze of the mice. So a one-way ANOVA test is an analysis of variance to see if there's a statistically significant difference between any of my test groups. So it will show me if my group of mice in the control group gained significantly more or less weight than my mice in the synthetic preservative group. And through this, I was hoping to prove that the mice in the synthetic preservative group gain more weight over time compared to the control group and natural preservative group, and had decreased cognitive function and a slower time through the maze from start to finish compared to the natural preservative and control preservative group. Unfortunately, because I had so few data points, it showed that there was no statistically significant difference between any of my groups for the weight gain over time and the time through the maze. This was not what I was hoping to see, especially because I was trying to make the claim that synthetic preservatives were causing these negative health results in the mice. But I do think that it was just because I had so few data points. And then for my gut microbiome health, the way I analyzed this was through a two-way ANOVA test, which is very similar to a one-way ANOVA test, except it looks at specific data points within my trials and compares it to each other, and it's a little bit more specific than a one-way ANOVA test. Unfortunately, across all my rows and columns and throughout all of my groups, there was not any statistically significant difference shown through my data. This was also not what I was hoping to see. I was hoping to see fewer bacteria counts from start to finish for my synthetic preservative group, but unfortunately that did not happen. So looking at my experiment as a whole, it's kind of easy to say like, hey, this didn't really work out, like what happened here. But I'd like to emphasize the fact that I didn't have the proper financial resources to really make this happen. And if I had a college level research facility and funding, and I had a little bit more, a lot more mice to test with, I would be able to hopefully have better results. But I did learn a lot from this experiment, and I think it really helped me understand the scientific process more, and how testing with mice actually can be applied to comparative medicine and different research avenues. If I were to do this project again, I would really focus on keeping the mice a little bit more separated. I would have larger enclosures with fewer mice in it, just to make sure that they were that their temperament was kept consistent, and that they were not trying to fight each other as much. I did observe some positive behavior with the mice, but because of how many mice were displaying food aggression, it kind of overwhelmed my statistics. In the future, I think it's also really important in the food market to look at how processed sugars and artificial sweeteners and artificial food dyes are affecting cognitive function and weight gain, especially as the childhood obesity rates within the United States are really picking up, and America is known for the amount of processed foods that are in our food market. So I think it's really important that we continue to focus on what is being added into our food without us really knowing. All right, well, thank you all for listening. My name is Rachel, and I would be happy to continue my podcast. So if you want to support us, just you can let us know in our link in our bio. You can also look at our resources and how I researched and prepared for my research project in our bio. The specific research article that I referenced can be found at the top, and I would be happy for any feedback or things that you guys want to know about, because we are debunking science on this podcast. All right, well, thank you for listening to Sorry to Burst Your Bubble. I'm Rachel. Have a good day.